Dear students, module number 4 we are already discussed for the RC phase shift oscillator and Wien bridge oscillator. The next is astable oscillator using IC355 timer. First we are going what is IC355 name. IC355 is there. Here 555 timer means timing circuit. 555 term is 5 kilo ohm resistor. 5 kilo ohm resistor. 3 resistor is used. That is the name as 555 means 5 kilo ohm resistor. 5 kilo ohm, 5k plus 5k plus 5k, 3 resistor is used. That is known as the name as IC355 timer. Using IC355 timer, you can generate the precise time duration of the high and low output voltage from the each microseconds. In this IC355 timer, this is the IC circuit diagram, IC chip. For each chip it is required. What is the 555? That is the first total 8 pin IC. Here is the 4. Here is the 4. Total 8 pin IC of this 355 timer. The first one is ground. Pin number 2 is trigger. Pin number 3 is output. Next is reset. Pin number 5 is control voltage, threshold voltage, discharge, and pin number 8 is power supply. This is the pin configuration of IC355 timer. Next, this is the main circuit diagram of IC355 timer. Here, what I told, IC355 means 5 kilo ohm, 5 kilo, 5k, 5k, 3 resistors is used in input side. Here also 2 op amps for the input side. One is the flip-flops, 2 op amps, that is upper comparator and lower comparator, 2 comparator circuits. One is the flip-flops, RS flip-flops, and 1 transistor, 1 output pin voltage. This is a circuit, the basic circuit of 555 timer in astable mode. Here is using the 3 resistors, that is a charging, discharging mode, threshold pin. Each pin, what pin we have, all 8 pins is used in this circuit diagram. See here, pin number 7 is discharge pin, pin number next is 6 is threshold pin, pin number 2 is trigger pin, and pin number 1 is ground, and pin number reset pin number 4, and here is power supply is pin number 8, and each pin is, and output pin number is 3. All pin number is using of this circuit diagram, and this circuit is using of IC, and this is the circuit diagram, and this is the output waveform of on that. How that 555 timer will be work. In this circuit diagram, for the charging and discharging period, again charging. Why it is charging and discharging period? 2/3 VCC and 1/3 upper voltage is 2/3 VCC and below voltage is 1/3 VCC. And when it is high voltage, in the how it is work? When it is high voltage, it is a charging period. When it is a low voltage, it is a discharging period. When capacitor is charging means when is current flow in the circuit, the capacitor will be charges some point. When is current will not flow, the capacitor will be discharging period. Current not flow means this is a low circuit. Okay, this is a basic circuit, and this is the waveform of the IC355 timer. And next is the basic circuit diagram, the main circuit diagram of astable oscillator using IC. This is the astable oscillator circuit diagram. In this, what your pin is, all pin number, what pin you are used for this all 8 pins. Here you use for the all 8 pins. See what are those pins you have to use here. See pin number 4, pin number 8, 7, 2, 6. All pins you have to use here, and with signal pin number 7 is discharge, trigger circuit, threshold voltage. Then how this circuit is work? Okay, this circuit is used for the 2 resistors R1 and R2, and next is capacitor is C1 and C2. Okay, and charging and discharging period output waveforms. In the astable oscillator, output is a square wave, and here are 2 output signals is coming. One is the charging and capacitor voltage, and next is the output signal. Here 555 oscillator is another type of relaxation oscillator for generating the stabilized square wave output waveform of either a fixed frequency up to 500 kHz or of varying duty cycle of from 50 to 10%, 100%. During each cycle, capacitor C charges up through the both timings resistor R1 and R2. What is that? each capacitor, this each capacitor is charging through the both resistor R1 and R2, but discharges itself only through the resistor R2, as the outside other side of the resistor R2 is connected to the discharge terminal pin number 7. Here two resistors is used to the charging and discharging period R1 and R2. Here the two waveform signals, one is capacitor voltage, the second one is the output voltage. The astable oscillator output is a square wave. When it is here, signal will be high, the capacitor will be charges. When signal will be low, the capacitor will be discharges. When it is charging, discharging, charging and discharging period, and output voltage when it is high and low. Next, and in this the circuit diagram, there are four conditions is work. What are the four conditions is here? One is the astable oscillator charge and discharge times. Second is the 355 timer oscillator cycle time, and the next is frequency equation. Next is a duty cycle. This is a four condition is the very important of this circuit diagram. How to this circuit diagram is using of these four condition. First condition is oscillator charge and discharge time. The total time T1 is equal to the fixed equation 0.693 R1 plus R2 into C. What is that? R1 plus R2 into this capacitor C, and 0.693 is the fixed value of using of in the oscillator circuit using a astable. Next, time T2, second time 0.693 into R2 into C. The discharging capacitor here using of this R2 into C. First time will be T1 is equal to R1 plus R2 into C, and the second time T2 is equal to R2 into C. This is a charging and discharge. The charge period is charging time is T1, discharging time is T2. Next is a cycle time, total time T1 T2. The total time T is equal to T1 plus T2. That is a T1 plus T2 means add these two 0.693 R1 plus 2 R2 into C. The total time T is equal to T1 plus T2. Next is frequency of equation. What is the frequency? F is equal to 1 by T. Means F is equal to 1 by T means only one cycle time period. Only one cycle time period means the only one time period. This is a time T1, time T2, total time T. This time T is equal to one cycle. F is equal to 1 divided by T. In this frequency, both high and low, the time is T1, T2, both T is equal to T1 plus T2. This is a T1 is charging, T2 is a discharging. That is a T is equal to T1 plus T2. And what is the frequency of in this full one cycle? The total time T, the frequency of this cycle is F is equal to 1 divided by T. Therefore, the frequency equation is 1 by is equal to T. That is 1.44. The equation is R1 plus R2 into C. The next, duty cycle. The duty cycle total, the main important is of the oscillator circuit using 355 timer as astable oscillator. You calculate the final duty cycle. The duty cycle is equal to T on divided by T on plus T off. What is the T on? T on means R1 plus R2. T off means R1 plus 2 R2 into what is the duty cycle? How much percentage? If there may be 60% or 70% duty cycle, with depends on the resistor R1 and R2. Depends on resistor R1 and R2, it will be changes of the duty cycle. Then the capacitor charges up to 2 by 3 VCC, the upper comparator limit, which is determined the 0.693 R1 plus R2 combination, and discharge itself the 0.693 R1 combination. Okay. This is the circuit diagram of astable oscillator using 355 IC. They will be asked the question, explain with neat circuit diagram and waveform with the working equation of this astable oscillator. This is the using of how to calculate the T on. Here astable oscillator is you have to calculate T on plus T on. T on means charging period and T off means discharging period. This is the working condition of the astable oscillator. One problem is there for about in this equation for the what is the charge and discharge time, oscillator time, total time, frequency equation and duty cycle. One problem about in this for here. These all four equations you have to use. You are to discussing this problem. First is the problem statement. The problem statement is astable 355 oscillator is constructed using the following components. The R1 is given 1 kilo ohm, R2 is 2 kilo ohm, and capacitor is given 10 microfarad. Calculate the output frequency from the timer oscillator and the duty cycle of the output waveform. In this, they calculate the total output frequency of oscillator. Okay, you have to use these formulas and use the time T1 capacitor charge on time T1 is equal to 0. The formula, and 0.69. What is the R1? R1 is the 1 kilo ohm and plus R2 is the 2 kilo ohm, and capacitor is given 10 microfarad. Therefore, T1 is equal to 0.021 second or 21 millisecond. And capacitor, and next is discharge time. Off time you have to calculate. T2 is equal to capacitor discharge time. T2 is equal to 0.693 R2 into C. That is R2 is given 2 kilo ohm and capacitor is 10 microfarad. Therefore, T2 is equal to 14 millisecond. And total time T is equal to T1 plus T2, means T1 is the 21 millisecond, T2 is the 14 millisecond, total is 35 millisecond. Next you have to calculate the frequency. F is equal to 1 by T. What is the T? Total time 35 millisecond. 1 by 35 millisecond is equal to 28.6 hertz. Therefore, the frequency of oscillation of this, the resistor, the 1 kilo ohm and the 2 kilo ohm, the frequency is 28.6 hertz. And next is calculate the duty cycle. The duty cycle is equal to R1 plus R2 divided by R1 plus 2R2. The R1 is 1 kilo ohm, 2 kilo ohm divided by 1 kilo ohm plus 2 into R2. The total is 0.6, means 60% of duty cycle. When you give the resistor R1 is equal to 1 kilo ohm and 2 kilo ohm, if capacitor is 10 microfarad, your duty cycle is 60%. When it is, if resistor is changing, if resistor is R1 is 5 kilo ohm and R2 is 10 kilo ohm, capacitor is 1 microfarad, your duty cycle will be changes. Your duty cycle depends on the resistor R1 and R2. This is the Astable oscillator using 555 timer.